everyone. So we're students at Georgia Tech. We're located in Atlanta, Georgia, and we're here to talk to you about a course that we are in, which is ME 1770 Intro to Engineering Graphics, and it's basically a class where we learn about various software used to model and design parts to construct a real-world device or machine. So we're mechanical, civil, and aerospace engineers, and we can't wait to introduce our project to you.
The main project that we've been working on this semester is a 3D CAD project. We were assigned to modify a design from the previous semester. It's an all-terrain vehicle that runs off of alternative energy. This was done, we have 3 different sections that have been working on this. Each have made their own unique improvements to the previous design. We used Autodesk Inventor in order to accomplish this. It's a software where you can start off with sketches and apply dimensions, and then you can do things such as extrude and create 3D features that you can modify to change your design.
This is section D, and the changes that we made to the original dune buggy was that we added tracks to it instead of 4 individual tires, and we also added a propulsion system that can lift the dune buggy into the air and get it over any sort of terrains.
So in the first part of the design process, each team member did some research on the parts and the features that we're using in each of the parts. And we started by drawing the isometric sketches and multiples of each individual part and dimension, full dimension of every single part and multiples.
Once we finished that, we started working with the features that we had. So using features, for instance, like a round, I was able to use that feature and extrude to create the bolt that goes all the way through my track system.
After we have created our parts, we use assembly to assemble every part into assemblies.
Okay, so for designing tracks, a couple of features I had to double check on was one, I had to look at ask the teams in our sections how long the total length of the dune buggy was going to be, so I can find out how wide each track needs to be. Then I also had to check with Zeth, who was designing the rims, to find out what the depth of my tracks needed to be.
So dimension of the rims have to fit the length of the car. When we assemble the track system, the rim can fit into the drive shaft with the bike.
The main thing I had to keep track of while creating the drivetrain was to make sure that the diameter of the axles fit the track and the rims. And then once these guys had their assemblies ready, I could attach the rim and the track onto my axles to create a more cohesive structure.
And as far as the engine was concerned, we were planning on creating the turbojet engine inside the ring. So the inner diameter of the ring that was designed by Zeth was certainly the main constraint for me to find the right turbojet engine that would fit inside the ring without having the propellers touching any parts of the ring. It's very important for the propellers to be outside of the ring. So that will automatically set up a lot of constraints for my part. I also have to make sure the engine is central with the circle and the inner diameter of the ring to be able to get the same amount of torque equally from all four sides to maintain the stability of the dune buggy when it's hovering on its ground.
Section M focused on modifying the frame and floor plate along with the suspension system and interior components. Yeah, my primary focus when I was designing the suspension system was I was worried that I had to give enough ground clearance for certain components to go into the dune buggy, like the drivetrain. So I spent a lot of time playing around with the suspension height. Also had to communicate with our group member at the time, the frame, to let them know how my suspension system would attach to the frame. So it was very important for me to do just good communication.
For the door, I had to first design the door, and then design hinges, bolts connected to the open doors, and I did a door frame to fit all this. And when I was building it, I decided that I could attach, to have the dash actually attach to the door frame using a screw with it. That way, when I put it all onto the door plate, it all fit. And
I had to modify several components of the body to the floor plate to adjust for the interferences that were occurring. So those the new light systems and tread systems. I had to make my floor plate longer. I had to add arms onto the frame of the tread system and the shock system attached to it. And we had to also move some of the arms, the extrudes, on the frame to allow space for the
I had to modify the pedal assembly by adding a clutch to the original pedal assembly to make it free, and had to communicate well with other members in order to make sure there's enough space for, or to make sure there's enough space so there's no interference with the dashboard or the seats. And I also designed the gearbox assembly just using simple super lock features.
In modifying the seat, I tried to, rather than make it a flat design, make it a ribbed design on the seat in the back, and to indent the seat as well as the back to fit more room on the passenger. In creating the seat, I did encounter interferences while mirroring it across the plane, but there was no interference with the new buggy itself.
We're Team C, and our primary task was overhauling the powertrain assembly. When we received the new buggy, the original file, the engine, the transmission, the electric motor. It wasn't really an assembly, it was more just sort of a random array of parts that weren't really connected in any sort of way. So our primary goal was to get the transmission more functional and to get the overall assembly in order so that we could transfer power from the engine to the axles, to the drive shafts. And we also made a couple other minor changes as well, but we'll get to those in just a second.
For the transmission, I had to create a shaft going into the transmission that connects directly to the engine. It has 6 gears that interlock with 6 other gears onto another shaft going out of the engine, which connects to the axle. This eventually drives the power to the wheels, and all of this is encased within the transmission case.
One first thing we realized when we started the assembly is that the engine and all the pieces for the powertrain were kind of just randomly arranged. So when we went to organize them, we realized that there wasn't enough room in the compartment, the engine compartment, to fit it all together. So we had to change the size of the transmission case, first of all, to make sure everything fit, and so they could all be accommodated in there. I had the steering wheel that I designed. I had a design to make sure that the steering column, the diameter for it, and as well as the length would fit the old system as well. And I ended up changing that later, but that was part of what I would put into the design phase for that. And then when I had the current system, I had to make sure I designed it so that it would fit in the engine, and the PCU I had to make sure it would fit in with the engine bay.
And when I was working on the gearbox assembly, I had a shift lever to attach to the actual gear shift, and then a shaft clutch that attached to that, which is an actual fork clutch, which you then turn and attach to the transmission. And in adjusting the gearbox assembly, I had to add a hole screw in the previous gearbox to allow for the shaft clutch to pass through. and I had to constrain all of these parts together while still allowing the shaft platform and the foot push to rotate and transmit the power and transmit the signal to the transmission.
The all-wheel drive axle assembly that I worked on consisted of 4 parts. The main part was a housing component, which was kind of in combination with the axle. Then on the exterior of that part were, attachment components that connected to the treads and the outer part of the all-terrain vehicle. I also had 2 components that were vertical and horizontal attachments that were used to attach the axle system to the body of the vehicle. The main problem that I encountered was matching the dimensions of this axle assembly to the dimensions of the vehicle, just to make sure that it could fit underneath. Also, I had to modify the dimensions of the housing component several times to make sure that it was small enough to fit underneath.
The wind turbine consists of frame, the dynamo, the blade ring, the 12 individual blades. The way it works is that the frame is the part that is attached to the body of the dune buggy. The dynamo is fixed inside of the frame and is the part that contains the electric generator. The blade ring sits inside of the dynamo and is the part that spins, and then the 12 blades are symmetrically attached to the blade ring, and as the wind blows it makes the wheel spin.